Hey folks, welcome back. So in this video, we're going to look at how to secure our gRPC connections using TLS. So there are three different types of connection in gRPC. There is insecure, which is what we've been using so far up to now in this course. And this basically means that connection between the client and server is in plain text, so it's not encrypted at all. This is fine for simple examples, but this shouldn't be used in production. Next we have server-side TLS, which is what we'll look at in this video, and this is where communication is encrypted between the client and server, but only the server's identity is verified. And the final one is MTLS, so that's where communication between the client and server is encrypted, but also both the server identity and the client identity is verified. So for today's video, we're going to take the Hello World service that we've built in previous modules, and we're just going to adapt that to add TLS so the communication is secure. So one thing we'll need to make our communication secure to use TLS is we'll need some certificates generated. So in the make file, I've provided some make commands to generate all the certs that are required. I created this gencerts command that calls three other commands in the make file. The first one is genCAcerts. So this will generate a certificate authority, which basically acts as a third party to confirm the identities of all the parties involved. And that's this command here. This will first make a cert directory in our root directory of our project. And then it will create a certificate authority, certificate and key. And then we'll use that to sign both the server and the client certs. And then the next command is to generate the server certificates. So this will create the server cert and key. And we're doing that just for localhost for the time being. This will then be signed by our certificate authority. For this first video, we won't use these client certs, but we will use them when we come to doing the TLS portion of this. So let me start out by running the gencerts command to generate all the certificates. And now if I go back to the directory, we can see we have all our client and server certs as well as our certificate authority certs. So if we just look through this project, you'll notice that the code is just the same as what we've implemented before. It's just a very simple hello world handler that first checks the name is not empty and then just returns a message in the response with the name from the request. And then in the CMD directory, we have a client and server implementation as well. So the server is what we've seen before and so is the client. So to enable TLS, we need to make changes on both the client and the server. On the server side, we'll need to load in the TLS certs, and on the client side, we just need to configure the TLS config. So we'll start out by implementing the server side. Basically, what we need to do before we create our gRPC server, we just need to load in our TLS certs. So we can do that using the credentials package in gRPC. So this package is part of the Google gRPC library. And inside this credentials package, there is a new server TLS from file function. And this basically takes a path to the cert file and the key file. So in here, we can provide a path to our server.cert and our server.key files. Server.cert and cert/server.key. And we'll just name this TLS credentials. Pass an error as well. So this function will load these files and then it will create a TLS credentials object, which we can then use when initializing our new server. So we'll just handle the error first. Just call this failed to load TLS credentials. And then once we have loaded the credentials successfully, we can then use the server option, which is called tls.creds. And this just takes a transport credentials object, which is what this new server TLS from file function returns. So we can just pass our TLS credentials object into there. And that should be everything we need to do on the server side to enable TLS. So just to prove that this is now working, we'll run the server first, and then we'll run the client, and we should get an error this time because the client is currently trying to communicate in plain text. So you can see the server's up and running, which means these files have been loaded successfully. I think if they had not loaded, and if they were not found, or if they couldn't load for some reason, this function would have returned an error, and then we would have errored out of our run function here and closed down the server. So now if we try and run the client as well, we should see an error this time. And as you can see, we're getting this error reading server preface and a file. This is because the server's returning encrypted data, the client can't read it. So now on the client side, we just need to update the transport credentials configuration and then allow it to communicate in TLS as well. Now this implementation can differ depending on whether you're using a self-signed certificate or a private certificate authority, or whether you're using a public one, Let's Encrypt for example. For this, we're obviously using a private one and self-signing our certificates because we've generated these files here. But it's quite common to use a public certificate authority, and this is something we will look at in later modules when we look at how to automatically refresh certificates and how to handle that within our gRPC services. If we were to be using a public certificate authority, it would actually be much simpler, this implementation. All we would need to do is use the credentials.newTLS function from the same credentials package as we used before and pass in a TLS config like this, and then we can just call this TLS credentials, and then pass that into our with transport credentials dial option that we have here instead of this insecure new credentials. Now if we were using a public CA, this would work fine and we wouldn't have to do anything else. However, because we're using a private CA, this obviously will not work, so I'll just comment that out. I will leave the code in there. So when using a private certificate authority, we need to load the CA certs and append them to our cert pool and pass that into these transport credentials dial option here. And that way the client will use that CA to verify the certificate that is passed from the server. So to do this, the first thing we need to do is create a cert pool using the new cert pool function, which comes from this crypto x509 package. And then after that, we load our certificate file. So this will be certs/ca.cert, and so this is the CA cert file from here. And let's handle the error as well. So just like before, if this cert can't be read for whatever reason, if this file can't be read, then this will return an error and we will just exit our application here. And now the next thing we have to do is call certpool.append certs from PEM, and then we pass our cert into there. And this will append our certificate authority cert to our cert pool, and then that means that the application can use this, or the client can use this when verifying the server certificate. So we'll just also, if this fails for whatever reason, we'll just exit the application here. And then finally, we need to create our TLS credentials object, which is what we will pass into this dial option. And to do that, we use the credentials package again, and there is a new client TLS from cert function, and in there we pass our cert pool, and the second parameter is a server name override string, but for our example we won't use that, so we'll just set that to empty string. And now we can pass our TLS credentials into this dial option, and that should be all that's required on the client side to allow the client to read the server cert and verify it. So now we've implemented both the client and the server side. Now let's try running our client again and seeing if we get a successful response. And as you can see, this time we got a successful response. So that's how we can enable TLS on our gRPC connections to make it secure. This is the easiest form of TLS because we don't require client certs in this example, and we're not verifying client certs. Now, in a lot of use cases, this will be sufficient, but of course there are some more secure use cases where TLS is required, where we need to verify the identity of the client and the server. So that's what we will look at in the next video. So I hope you found this useful, and I'll see you in the next video.